As with any type of hypothesis test, our first step is to go ahead and make sure we can list everything. When we're doing a two-mean test specifically, our list is going to have two different columns. We'll have one for sample 1 and one for sample 2. Now because we're dealing with two means here, we'll go ahead and we'll list the mean for each, so x1 bar and x2 bar, and it's worth noting at this point that it doesn't matter which one we use as sample 1. I'm going to always choose sample 1 to have the higher average so that when I subtract them, I get a positive. But in reality, it doesn't matter. So I've got x1 bar and x2 bar. Next, I'll list the standard deviation for each, S1 and S2. Then I'll list the sample size for each, N1 and N2. After this, I'll list the difference, x1 bar minus x2 bar. And I list this because, once again, every two mean or two proportion problem we deal with here is going to be looking at the differences between our sample. What we're really concerned with is there a difference? That is, can we take that difference and can we use it to generalize about the population? So that's why we find x1 bar and x2 bar. The final thing we need to go about listing is degrees of freedom. And the thing to remember here is that degrees of freedom for two samples is not nearly as nice as the formula for degrees of freedom with one sample. If you haven't already written this down, go ahead and check out the video on how to find degrees of freedoms for two means. Our second step for any hypothesis test is to go ahead and write down, well, our hypothesis. Because we have two samples, our hypothesis, H naught, will be based on the assumption that in reality our populations have the same average. That is, despite the fact that our samples, x1 bar and x2 bar, might be different, that if we pulled everyone in population 1 and everyone in population 2, the averages will line up. Now, in order to do this, we need to remember that x bar is the sample average, and the population average is actually mu. So I'm going to write mu1 is equal to mu2. And what this is assuming here is that in reality, my populations have the same average to them. My alternative hypothesis is the opposite. That is, I'm going to write mu1 and mu2, and I'm going to have a couple different options for what can go in between here. Now, we know from before that I can put a greater than. If I'm trying to show that mu1 is more than or greater than mu2, I can put a less than if I want to show it's less than or under or lower. And finally, I can use a not equal to if I want to show there's a difference between the populations or if something's changed. Keep in mind here that these top two are a one end tail, which means I'll use the t-table just as written, and this bottom one here is a 2 end tail. And what that means is once I find that p-value, I will double it.